I'm Tyson. I'm a research assistant professor at University of Arizona, and I'm co-PI at CyVerse. I changed my title at the last minute from our moniker, which is Cyberinfrastructure for Data-Driven Discovery, to making cloud more accessible and inclusive. Inspiration for this slide came from Ryan Abernathy's recent talk at the Open Ocean Cloud, talking about building inclusive communities and working with cloud data. And so the idea here is that we have a problem with modern cyber infrastructure. We build more complex clouds. Commercial cloud is accelerating. Every year there's a new offering. And we have these data fortresses where large institutions like my own privileged institution that have large CI investments, we're creating barriers that folks at smaller institutions, underserved communities are unable to access these data. And this limits knowledge transfer, and it ultimately hinders scientific discovery. So the solution to this is that we focus on these three pillars of cloud native science that Dr. Abernathy proposes with his collaborators on this recent cloud native repositories for big scientific data paper. So the pillars are cloud optimized, analysis ready data, data proximate computing, and dynamic and elastic scaling. So we think about couching ourselves forward to this framework. And when I think about cyber infrastructure, the first thing that I think about is probably something like a data center. And then I remember that we have to use software and analysis code, and we work with data on these things. And I would guess that for all of us, the last thing we think about are the people who are necessary to support these and to provide training in the use of these things. And this is one of the most critically overlooked components of CI. This survey from 2017 asked 704 NSF PIs what their most critical needs were, and they were not access to compute or data storage. They were all training. So we have a workforce that is falling behind in the use of cyber infrastructure, and we have to catch up in this regard. So the way that CyVerse tries to manage this is that we have an open source platform which tries to bookend the research object. So we start with collecting data, analyzing data, providing a platform where you can bring your open source software to work on these and then share them with your collaborators. And then we push this on through training to try to get other people to do this. Our platforms include this one on the left, which is our discovery environment. It's a Kubernetes-based data science workbench. We can integrate popular integrated development environments and allow users to build from these their own applications, or to bring any Dockerized tool and run them on our platform. As Jeremy just showed us with Jetstream 2 on the right here, we're working on the new version of Atmosphere, which is codenamed Cacao for now, but it's the ability to come in and rapidly deploy a cluster and provide authentication to your users and give them the container that they need to do their research or to teach their lessons. So this Lego block approach is the way that we're bringing it to it. The platform, I'm not going to go over these, but if you're interested, you can look at the slides online. On the left, we're using a Kubernetes platform for our integrated development environments running the containers, and these are backed up to our iRods data store, and you can also access commercial cloud from there. And then our executable workflows that are non-interactive apps are deployed using a combination of tools that we've built there in pink, and then those are all run through Condor. And one of the things that we've focused on over the last 13 years is training. And so trying to build these inclusive communities of researchers who don't have the necessary skills necessarily to do reproducible research. And it's humbling to show up at a workshop after 2 days, having just shown people Docker, shown them GitHub for the first time. And folks can assemble viral genomes. They can do phenotyping of plants, or even recreate the image of the black hole with a GitHub action. And so it's the reproducible science is there, and these people don't necessarily have to be a domain scientist to know how to do this by the end of a workshop. And we focus on the problems that we see students and early career folks having today. And these can be simple things like, how do I scale my analysis? Or I just want to graduate and I need to get this analysis done. Or how do I write a data management plan to get my first NSF award? And so our workshop series focuses on training these fundamental skills. And so which skills are most important? I would say that the fair data principles, as we learned about yesterday, are a critical skill. Doing open source software, either development or use of the software for your science, committing to publish in open access journals is important. Working with linked and open data using ontologies and schema and metadata, which can make your data findable. And then the last part is having this DevOps mindset of, from the onset of your project, building reproducible workflows that can be rerun at the end and can be shared. So the way we do this is we have a professional services group, which focuses on training and support for our folks. As I said, we try to create a research object. So we follow the entire life cycle of data and training. We're out there trying to teach people how to do this stuff constantly. CyVerse is funded by the National Science Foundation, and we're grateful for its support. And thank you all for listening.